Hello everyone, my name is Emre. Today I will be presenting my last intern IE397. I will divide my presentation four main points which will be begin with introduction and end with conclusion. In introduction, Nevsaj Boru has been steel manufacturer in Turkey, also top 200 manufacturing industry in Turkey. Let me go through the system under consideration. Pipes are manufactured within some order, also decision point. This decision point represents if the selected product will be pipe, steel pipe, or profile. Supply of raw metal sheet begin the processes and continue to some cutting processes, also welding processes. Also, there is a cooling pool process. And the last process is the shipment or sending products to the customers. The most important system processes are unrolling and cutting machine, welding machine, and cooling pool processes. Especially welding machine, because the welding machine represents the sizes of the steel pipes and profiles. Let me go through to the methodology part. In methodology part, I analyzes the problem in Nevsaj Steel Company by drawing fishbone diagram, measurement, people, environment. Most problems are coming from the hygiene, also some old gauge use. Also, there are some engineering issues. These parts represents the data, old data of profile with sizes of 3031 and this data related with thickness of this profile. I have collected the sample size 10 and number of sample was 25. Then statistically I illustrated the X bar chart because there is a thickness measurement. X bar chart and S chart would be available for it due to sample size and the measurement type, which is thickness. As you can see from this graph, there's a one assignable cause, upper control limit, as well as the upper specified limit. Specified limit, by the way, also coming from the TSE, which is a Turkish standard. Also, there are more fluctuations, wave-like shapes, more and more. Let me go through the S chart. In the S chart, there is no point out of the boundaries. the upper control limit as well as lower control limit. Deviations are too much, and downside deviations are much longer than the upper side deviations. Also, most deviations are the 16th sample. How can I improve this system about the thickness? I suggested the increased hygiene, new gauge order, and more maintenance for machines, especially welding machine. These NIF data, I took 25 15th sample subgroup, and each subgroup contains 10 sample size. When I increased the hygiene, new gauge order, more maintenance for machines, system will be improved. We'll see. This is the new X bar chart after monitoring the thickness of the profiles. It is There is no out of boundaries, upper control limit as well as specification limit. Also, we have to take attention for the specification limit, TSE standards. Specification limit will be ruled by this. After that, there is a less, very less fluctuations as well as the meet the TSA quality control standards. What about S chart for after monitoring the system and improving the system as well? Fluctuations or stabilized and flattened. This is still in the order like the previous one. Even is there is a some sample in the limit of central line. Other than profiles, I will be talking about steel pipe with size of 2020. This chart represents combination of the there is a P chart nonconformity rate. Before the improvement, there are lots of error rate, nonconformity rate in the steel pipes, and to implementing the same methods like the predecessor one, which is profile. Still, this method is applicable for also steel pipe. We can see from the data and the chart I will illustrate later. This is the P chart, combination of P chart of steel pipe. You can see there is no just one assignable cost. There is a lot of fluctuations, errors, especially on the upper control limit, as well as lower control limit is out of boundaries in some sample subgroup number. After improving the system, average of P, average of nonconformities are reduced greatly. Also, upper and lower control limit have reduced almost 50%. As a conclusion, I analyzed profile with size of 30, 30 and thickness with 1 centimeters via XBAR and XChart because of the sample size and available data. For steel pipe, I get support from the mechanical engineers. They are also responsible for quality control in company. Also, I suggested them to observing the system in a long duration because this is the short term solution. We cannot say our solution will be okay with long term. Also, I suggested them to getting a data from steel pipe related with their parameters like radius or thickness a tiny bit. This is the end of my presentations. Thank you for listening to me.